Good evening again. I'm restarting Lecture 10. I had a power outage and I lost my earlier version, most of it anyway. I was able to capture some of it. So I'm restarting back at encryption, and we'll continue with this, the second part of Lecture 10. It'll be designated Lecture 10b. Encryption is encoding information using a mathematically based program and a secret key. Cryptography is the science of studying encryption, and it converts text that is legible into text that has no apparent meaning. Encryption programs transform normal text, plain text, into ciphertext. In other words, an unintelligible string of characters. The encryption algorithm is the logic behind the program, and it includes mathematics to do the transformation. The decryption program is an encryption reversing procedure that decodes or decrypts messages. In the United States, the National Security Agency controls the dissemination of encryption algorithms. It's illegal for U.S. companies to export these algorithms. An encryption algorithm ensures that the message cannot be deciphered without the key used to encrypt it. Hash coding uses a hash algorithm to calculate a number value, a hash value, from a message. It provides a unique message footprint. We can determine if the message was altered during transit, if there's a mismatch between the original hash value and the receiver computed hash value. Public key encryption, also known as asymmetric encryption, encodes messages using two mathematically related numeric keys. The public key is freely distributed and encrypts messages using the encryption algorithm. The private key is secret and belongs to the key owner, and it will correctly decrypt all messages encrypted with that owner's public key. Symmetric encryption, also known as private key encryption, works so that it encodes messages with a single numeric key to both encode and decode the data. Both the sender and the receiver must know that key. It's very fast and efficient, but does not work well in large environments because of the number of keys required to be sent to all of the various participants. The data encryption standard, DES, was the first U.S. government private key encryption. A triple DES was a stronger version of DES, and Advanced Encryption Standard, AES, is a more secure standard that is commonly used today. Comparing these two systems, the advantages of a public key or asymmetric system is the small combination of keys required. There's no problem with the need to distribute the keys to all the players in the system. And there's an implementation of digital signatures that is possible with this approach. The disadvantage is that public key systems are significantly slower than private key systems. Public key systems complement rather than replace private key systems. A web browser's secure socket layer protocol provides a security handshake in which client and server exchange a brief burst of messages. They agree on a level of security, and all communication is encrypted. So eavesdroppers receive unintelligible information. It secures many different types of communication. To implement SSL, precede the URL with the protocol name HTTPS. Secrecy is implemented using a combination of public key and private key encryption. The browser generates a private key and encrypts it using the server's public key. The browser then sends that encrypted key to the server, which decrypts the message and exposes the shared key. After the secure session is established, the public key encryption is no longer used. Message transmission is protected by the symmetric or private key encryption. Any new connection requires the entire process to be restarted, beginning with the handshake. There's an older SHTTP protocol. This was an extension to HTTP for providing secure features. It did a session negotiation, setting the transmission conditions that occur between the client and the server. It established a secure session with a client-server handshake that includes security details, such as a security envelope that encapsulates the message. It provides secrecy, integrity, and client-server authentication. However, SSL has largely replaced S-HTTP. Hash functions. To detect message alteration, a hash algorithm is applied to the message contents to create a message digest. The receiving computer can calculate the value to determine if the numbers match, which indicates there was no alteration, or if the numbers do not match, showing that there was an alteration. A digital signature is an encrypted message digest created using a private key. It provides non-repudiation and positive identification of the sender, because only the sender's public key can decrypt this digital signature. In many states, it has the same legal status as a traditional written signature. And here we see a diagram of the various actions, a hashing function that takes input and outputs a numeric value, numeric hash, and that can be in hexadecimal form. We also have the private key, where we get plain text and use a common private key to encrypt it. Both parties use that key both to encrypt and to decrypt. And finally, at the bottom, we have public key encryption, where the receiver's public key is used to encrypt the data, and then the receiver uses their private key to decrypt it. And here's the steps that one would go through to establish an SSL session. And here's the whole process of sending and receiving a digitally signed message. So the hash is encoded using the private key of the sender, and then the receiver will use the public key of the sender to decode the signature and get the message digest. They'll also perform the hash on the message itself to get another message digest, which should be equivalent, and then the comparison is made. Let's now look at security for client devices. And this topic includes threats to computers, smartphones, and tablets. And those threats can originate in software and also in downloaded internet data. Cookies and web bugs. The internet connection between web clients and servers is accomplished by multiple independent transmissions. There's no continuous connection maintained between any client and server. Cookies are small text files web servers place on the web client to identify returning visitors. They allow shopping cart and payment processing functions without creating an open session. Session cookies exist until the client connection ends. Persistent cookies remain indefinitely. Electronic commerce sites use both. Cookies can be categorized by their source. First-party cookies are placed on the client computer by the web server site. Third-party cookies originate on a website other than the site being visited. For complete protection, completely disable cookies. However, that means that useful cookies would be blocked as well, and so the full site resources may not be available. A web browser cookie management functions can be set to refuse third-party cookies or can be set to review each cookie before allowing. A web bug or web beacon is a tiny graphic that third-party websites place on another site's web page. It provides a method for third-party sites to place cookies on a visitor's computer. It's also known as clear GIF or 1x1 GIF because the graphics created are in GIF format, and they usually have a color value of transparent, and they can be as small as 1 pixel by 1 pixel. Active content. Active content programs run when client devices load a web page. Example actions include playing an audio, displaying moving graphics, placing items into a shopping cart. The methods to deliver active content include cookies, Java applets, JavaScript, VBScript, ActiveX controls, graphics, web browser plugins, and even email attachments. Scripting languages provide executable scripts, JavaScript and VBScript. Applets are small application programs that typically run within the web browser. Most browsers include tools limiting applets and scripting language actions by running in a sandbox. ActiveX controls are objects containing programs or properties placed on web pages to perform tasks. ActiveX controls are only available on Windows operating systems, and they give full access to the client system resources. Crackers can embed malicious active content. A Trojan horse is a program hidden inside another program or a web page that masks its true purpose. And it may result in secrecy and integrity violations. Zombies are programs that secretly take over another computer to launch attacks on still other computers. Graphics and plugins. Graphics and browser plugins and email attachments can harbor executable content. Browser plugins are programs that enhance browser capabilities but can pose security threats as well. Physical media for client devices. Client computers require physical security. This can be in the form of fingerprint readers or biometric security. Also, access passwords help secure mobile devices, and mobile devices have remote wipes functions that clear all personnel data and can be added as an app or done through email. Many users install antivirus software on their mobile devices. And here we see the Mozilla Firefox dialog box for cookie management. Okay, communication channel security. The Internet's packet-based network design precludes it from being shut down by an attack on a single communications link. Individual users' internet service can be interrupted, however, and that's by the destruction of the user's internet link. Larger companies or organizations use one or more links to maintain an internet backbone. Threats to wireless networks. The wireless encryption protocol, WEP, is a set of rules for encrypting transmissions from the wireless devices to the wireless access points. War driver attackers drive around in cars and search for accessible networks. War chalking is placing a chalk mark on buildings where open networks are found. Companies can avoid attacks by turning on the wireless authentication systems and changing a default login and password settings. Best Buy wireless point of sale failed to enable this capability, and customers' data was intercepted. The internet was designed to provide redundancy, not to be secure, and that remains true today. Secrecy is the prevention of unauthorized information disclosure. It's a technical issue requiring sophisticated physical and logical mechanisms such as encryption of emails. Privacy is the protection of individual rights to non-disclosure, which is a legal matter. Should a supervisor be allowed to randomly read an employee's email is a privacy concern. The theft of sensitive or personal information is a significant electronic commerce threat. Sniffer programs record information passing through the computer or router that's handling internet traffic. A backdoor allows users to run a program without going through the normal authentication procedures. Several companies offer anonymous web services that hide information from the sites visited. Active wiretapping is when an unauthorized party alters message information streams, and this is an integrity threat. Cyber vandalism is electronic defacing of a website, another integrity threat, and masquerading or spoofing is pretending to be someone else or establishing a fake website that represents itself as the original website. Again, these are all integrity threats. Domain name servers are internet computers that link domain names to IP addresses. Perpetrators will use this system to substitute their website address in place of a real one. Phishing expeditions trick victims into disclosing confidential information. Banking and payment systems are a primary target. Necessity threats. Denial of service attacks disrupt or deny normal computer processing. And this is a necessity threat. You need to have your servers available, and they're not. This can be the result of intolerably slow computer processing by the denial of service attack, or the denial of service attack renders service unusable or unattractive. A distributed denial of service attack uses botnets to launch simultaneous attacks on a website. And our third link is security for server computers. The web server administrator enforces security policies on the server that should be well documented. One of the most sensitive files on a web server holds web server user password pairs. So those have to be encrypted. Password threats include also using easy passwords. A dictionary attack cycles through an electronic dictionary trying every word as a password. Solutions to this threat include stringent requirements and company dictionary checks. Password management software securely stores all of a person's passwords. The user only needs to remember a master password to get access to the program. Database threats. Most database systems rely on usernames and passwords that may be stored in unencrypted tables. If a database fails to enforce security, unauthorized users can masquerade as legitimate users and reveal or download information. Trojan horse programs hide within a database system. They can reveal information by changing access rights. Java or C++ programs executed by a server often use a buffer memory area to hold data. A buffer overrun or buffer overflow error occurs when programs malfunction and spill data outside their buffer. The buffer overflow can be an error or it can be intentional. An insidious version of buffer overflow attack writes instructions into critical memory locations. The web server resumes execution by loading internal registers with addresses of the attacking program's code. Good programming practices can reduce potential errors from buffer overflow. Some computers include hardware to limit the effects. Mail bomb attacks are another form of attack that occur when hundreds or thousands of people send a message to a particular address. Threats to physical security. Web servers and computers network closely to them must be protected from physical harm. Companies outsource hosting web servers, or they maintain the server's contents in backup copies at remote locations. The companies often rely on service providers for web security. Access control and authentication refers to controlling who and what has access to a web server. Authentication is identity verification of an entity requesting computer access. Server user authentication occurs in several ways. A digital signature containing certificate, a certificate timestamp, or a callback system. Usernames and passwords provide some protection. Many maintain usernames in plain text and encrypt passwords. Site visitors may save username and password as a cookie, which might be stored in plain text. Access control lists restrict file access to certain authenticated users. Firewalls are software or hardware-software combinations that are installed in a network and control packet traffic. They're placed at internet entry points of the network as a defense between the network and the internet, or another network. Firewall principles are that all traffic must pass through the firewall and only authorized traffic can pass through, so it makes it immune to penetration by outsiders. Networks inside the firewall are trusted, and those outside the firewall are untrusted. They filter messages so that only select messages pass through to the network. Firewalls can also separate corporate networks from one another. They can segment a corporate network into secure zones. Large organizations must install firewalls at each location and that all of those firewalls at the different locations should have the same security policy. Packet filter firewalls examine data flowing back and forth between a trusted network and the internet. A gateway server filters traffic based on the requested application and limits access to specific applications. A proxy server firewall communicates with the internet on the private network's behalf. Perimeter expansion problems occur when computers are used outside the traditional physical site. Intrusion detection systems monitor server login attempts. They analyze these for patterns indicating a cracker attack or block attempts originating from the same IP address. The growth of cloud computing is increasing the need for cloud security, which has lagged behind the security in-house. Personal firewalls on individual client computers have become an important tool for expanded network perimeters and protecting individuals and their data. And here we see examples of passwords that go from very weak to extremely strong. And we'll finish up looking at organizations and forensics. After the 1988 Internet worm attack, organizations were formed to share information about computer system threats. Sharing information about attacks and defenses for attacks helps create better computer security. One of the organizations that emerged was the Computer Emergency Response Team, or CERT. It maintains effective, quick communications among security experts to handle or avoid security incidents. It responds to thousands of incidents and provides security risk information and event alerts. It's the primary authoritative source for viruses, worms, and other types of attack information. Another organization is the System Administrator Audit, Network, and Security Institute, or the SANS Institute. And it's a cooperative education and research organization. Sirius is a center for multidisciplinary research and education, and the Center for Internet Security is a nonprofit organization that helps electronic commerce companies. Computer forensics experts are computer sleuths hired to probe PCs. They are hired to locate information that can be usable in legal proceedings. They have the job of breaking into client computers. The computer forensics field is responsible for collection, preservation, and computer-related evidence analysis. Companies hire ethical hackers to test computer security safeguards. And that concludes our lecture for tonight. I'll see you on the forums.